Good afternoon, class. Welcome back to CHE 351 Chemical Process Principles. Well, back to module 2.1. Remember, we finished module 1 and module 2. We're going to be looking at module 2.1, 2.2, and 2.3. They are all the basic concepts in chemical process principles. So basic concept 1, basic concept 2, and basic concept 3. So in this basic concepts 1, we're going to be looking at the following. Introduction, we look at industrial chemical process. There's a batch process and continuous process. We also look at process flow diagrams. We look at modes of operations, that is steady state and unsteady state operations, and we'll conclude. Industrial chemical process. Now, a chemical process can be defined as those activities in the industries which involve chemical reactions. So once chemical reaction is involved, automatically means we're talking about chemical production. And all these are classified as industrial chemical processes. These processes manufacture products that have different chemical compositions from the process feeds, which are usually naturally occurring raw materials or intermediates or waste. So these industrial chemical processes manufacture different kinds of products. Of course, we'll see that these products are very important to us. Using different process feeds, the raw materials, sometimes those raw materials are classified as waste. That is things that, does not make any meaning to anybody. But those waste can also serve as raw materials for production of other processes. On the other hand, it could be described as an integrated series of operations through which materials or energy is converted from one form to the other. So we can also describe industrial chemical process as a means by which we can convert materials and energy, or materials or energy, from one form to the other. Of course, we will remember our law of conservation of matter, or law of conservation of energy. So we'll convert raw materials from one form to another form, which is the finished product or intermediate. Now, following this, we see this scheme here. There's a process unit, energy input, raw material input. Inside the process unit, the process takes place. Process reaction, the chemical process takes place in the process unit. And then we'll have an energy output, and we also have a product output. Batch and continuous process. Now, batch process. In this process, a definite or a fixed charge enters the equipment and is produced and discharged. The input and output streams are not continuous. The finite amount of charge into the equipment, it is processed and removed before another quantity of feed is charged and the process is repeated. A very good example is evaporation of water from a mixture of sodium chloride and water. Now, another good example is, in simple terms, is the production of our soup. It's a chemical process. Somebody who has a function, maybe it's a wedding reception or it's a burial, you find out that if the person wants to cook food that will serve for maybe 1,000 persons, there's every likelihood the person cannot cook. It is not a continuous process where you keep adding, the soup ingredients and the guests will at the other end keep collecting the finished food. No. The person will get a pot, finish cooking the food, remove the pot, pour out the food. If that soup will not be enough, another set is also cooked. The same thing happens in fast food, and that's why they have their recipe. They have certain quantities of raw materials that they will measure, and then of course know what they will add to produce their finished product. So we can see that actually we carry out these processes even at home, in our kitchen, in daily life. And once this is a type of process that takes place, we say it is a batch production or batch process. Now, for continuous process, materials are fed into the system and leave the system uninterrupted as different streams. So that's why it is continuous. Raw materials are continuously fed in and products are withdrawn without stopping the operation within the operational interval. So it's a continuous process. As raw materials are going in, products are withdrawn, and the process is continuous. It does not stop in between. A very good example is evaporation of water from a brine solution. Of course, we know that we also have some industries that operate on semi-batch or semi-continuous, whereby it's not fully batch process or is not fully continuous process. Now we look at process flow diagram. This is also called process flow charts, usually presented in block flow diagrams. It is used to illustrate the sequence of equipment and unit operations in the overall process so that the manufacturing procedure may be visualized easily. Thus, the key processing steps are represented by blocks, and each block represents a unit of operation or a process step. Arrowed lines are used to indicate process streams, connected unit operations, or product and raw material streams. These must be labeled properly. The process flow diagrams sometimes show the quantities of materials and energy transfer, process and control instruments. The process flow diagram for a complicated process is prepared by making a well-labeled diagram showing input and output quantities connected to process units. With the help of carrying out material and energy balance, the stream quantities and conditions could be specified. So the process flow diagram helps for us to know, one, it gives us the location of all the process units, all the equipment, whether it's a pump, pressure gauge, heat exchangers, deodorizers, filters, sedimentation tanks, and the rest. Whatever unit operation, whatever equipment that is involved in the process line will be shown in the process flow diagram. And at the same time, some of them also show the quantity of the raw material coming in and the quantity of product that is also given out. So this process flow diagram helps us to monitor the process and also to know exactly at what point what is happening in any unit operation. Now this is a simple process flow diagram. Look at the inputs coming into this process unit. The vent here can be for water vapor, it can be for carbon dioxide, it can be for any other gas that is given out. Now, after this first process unit, the main process stream moves again to another process unit. We have just used only 2 process units here. In most industries, you can find more than 5, 6 process units connected. Now, this is the product and this is the waste. We can also have byproduct. This is a very simplified process flow diagram. You can also have a process flow diagram where you have a bypass. You have a bypass stream. You have a purge operations, and so on. But this just gives a picture of a very simplified process flow diagram. Process flow diagrams are of 3 general types. One is qualitative. This shows the flow of materials, unit operations involved, equipment necessary, and special information on operating temperature and pressures. Then you can also have it as quantitative, and this shows quantities of materials required for the process with operation represented in blocks. And then the third type is what we call combined detail. Now in this combined detail, what happens in the combined detail shows, in addition, the location of temperature and pressure regulations and indicators, as well as the location of critical control valves and special instruments. So you find out that this combined detail is actually showing us everything concerning that process. And under the combined detail, for each piece of equipment, accompanying tables give essential information. So it's a very detailed. You have both the process flow, you have the equipment, you have the pumps, you have the gauge. Everything is shown in detail. And these days, most of these process flow diagrams are computerized, such that it's easy for you to be in a computer room and monitor what is happening in all the process units and give back feedback to the production section for necessary maintenance. Because once there's any problem, the maintenance people will be alerted, and any particular unit operation or pump or any facility that is not in order will be fixed before that process can continue. Modes of operation. There are basically two modes of operations. These are steady state operations and unsteady state operations. So one, the steady state operations. At steady state, the condition at any point inside the process unit is constant. Once we talk about steady state, what comes to mind is this thing we normally say garbage in, garbage out. Input is equal to the output, and thus there will be neither accumulation nor generation in steady state operations. Steady state problems are treated as integral balances for fixed time periods. That is, there is no time variation. If no accumulation occurs as a result of steady state, we neglect its generation and consumption terms. Then we have that input minus output is equal to 0, or input is equal to output. That is garbage in, garbage out. This means that what goes in must come out. Now the second one is unsteady state operations. When changes occur at any point inside the process unit, we have unsteady state operations. So there is variation with time inside the process unit, and that makes it unsteady state. There is variation with time, and accumulation time is no longer 0. We have negative or positive accumulation. So accumulation can be positive or negative. So, of course, examples of unsteady state is where we have processes that start up, for example, the startup of equipment. So we can differentiate vividly between steady state and unsteady state. And of course, when we will use the law of conservation of mass equation, we will see the difference between steady state and unsteady state operations. So now, thank you very much. We've been able to come to the end of module 2.1, and we've looked at the industrial chemical process, we looked at the batch and continuous process, we looked at process flow diagrams, and we've tried to differentiate between steady state and unsteady state modes of operations. Thank you very much, and see you in the next module.